Hello, in this video I would like to visualize the audio spectrum that I tried recently using Houdini. It might not be really a Houdini job to do that kind of thing, but it was pretty interesting doing it, so I would like to show how I did it. Okay, so first of all, let's make a geometry as always. Go in here. And I would like to make a sphere as a base object to make it as a visualizer to visualize a spectrum, audio spectrum. Now let's show the edges with the polygon, and maybe I could increase the frequency so that I have enough triangles to use this as an spectrum bars. So I would like to extrude each triangles to the normal direction. And if I look at it, I right now have 500 primitives. That might be enough to test out, so let's do with this one. Okay, so first of all, right here I'm gonna use a audio file, so not this one. I need to create a chop network. So let's go inside the chop, and first thing I have to do is to import the audio file. Now I have downloaded this music from DL Sounds website, which provides royalty-free musics. This one, Chill House Loop. It could be any music files with the WAV format. So I'm gonna download this. I'm gonna use this as an example in order to visualize a spectrum. So in a file component, let's load the file chillhouseloop.wav, and then let's visualize this waveform that looks like this. Now, right now this is just a waveform of the sound, but what I would like to use this time for visualizing is the spectrum. So let's bring up spectrum, connect it, and let's visualize it. Let's horizontal adapt and vertical adapt, and I am seeing something here. Okay, let's make this to 0 and 1. Yeah, and I am having something here. Okay, so this is the spectrum of this audio, and as you can see, I'm having right now two channels, channel 0 and channel 1 must be left sound and the right sound. In order to visualize, I would like to make it as a one channel, so I'm gonna delete one of the channel. So right here I'm gonna choose channel 0 to delete. Now I have only channel 1, which could be a right side channel. Okay, let's zoom up a little. Okay, so it's the spectrum being mapped between 0 to 1, so it's like 24 frames. As you can see, the only wave that you can see is in between 1 to something like 1.5. So rest of the channels, I mean samples, I don't really need those. I just need those wave. And there's one more problem. As I move the frame, the spectrum is moving along with the frame, which I don't really want because I want to use those constant frames areas in order to apply to the channel, apply to the attributes on the geometry. So first thing, let's use the shift to not move this audio file even if I move the frames. Okay, so connect the spectrum to the shift, and let's choose an absolute 0, 0, which will make the position of the spectrum to be set on the 0 position always. Okay, that's good. And now let's trim this out to just use around here, and don't export the channel around here. So I'm gonna use like a trim component, and this is the end, but I can control the sliders to move this end value to the left side, and somewhere around 0.95 or 0.98. Yeah, 0.98 sounds good. Okay, minus 0.98. Now I have trimmed the spectrum. Let's look at the information, and right now I have like 882 samples, but I only have like 500 primitives, so I would like to resample this spectrum to fit around a little bit more than like 500 for this one. Okay, so I can use the resample, and let's see, so I could go like 25,000, I guess. 25,000, and that's around, yes, 500. Wow, that was exact. Okay, and would like to export it, so I clicked here, and for now I think that's all I need to do in the chop network. Now if I play this, looks like this. Now I might need to hear the real audio as well. So let's click the speaker icon here, scrub file, select the same audio. Okay. And let's try playing. Now I also need to click the real-time icon here. Okay, then let's play. Okay. I do notice a little bit of lag between the audio and the waves, so I might need to shift the spectrum a little bit to match with the audio. Let's see. The spectrum seems a little bit slow, so let's give a shift and place it around here, and let's say the start becomes a -1. And let's play that again. not. Maybe +1. +2. No, -2, I guess. Oh, one more. Okay, I tested some values here and it seems like -3 looks like a good number. So I'll go with this shift number. Okay, so I think I'm ready to export this. Wait a minute. So I have trim. Trim this. Okay, I have to make this 0. Okay, I think it's good. Well, I could always go back to do some coordinates. But right now it seems good, so I'm gonna go with this value on the resample, which has 500 samples. I mean 501, but it's okay. Now, the things that I want to do is to bring those channel value to each point or each primitives of this spheres so that I could use that value to extrude each triangles. Now, so first of all, what I'm gonna do is to, I guess I would, since I think the chop channels can be only transferred to the point attributes, so I gotta have to get the point out of this primitives. The easiest thing I could think of is to use pack to pack each primitive first to get the center point of that primitive. And in order to use the pack, I think I need to name this first. Primitive wrangle. I'm gonna use primitive wrangle to name each sphere triangles with unique name. Just gonna use a prim num because I think that's enough. Oops. Prim num. Something is wrong. Okay, I think I need to convert this into string. Right. Now let's look at the geometry spreadsheet. And on the primitive, yes, I do have a name here, and I'm gonna connect that to the puck and use the name attributes to pack each triangles. Now I'll be able to get the points on each triangle's middle, centers. It's good. Now this is where I'm gonna transfer the attributes, the chop channels to attributes, point attributes to here. Here. Now I'm gonna use a node called channel and connect that to the packed one, and the chop that I'm gonna refer to is a resample, and the channel scope, the name of the channel was chan1m. Okay, so I'm gonna write chan1m, and attribute scope, I'm gonna name it distance, and since I don't have a distance attributes in the point, so I'm gonna create first the attribute called distance for the point. Okay, float. Now if I look at the geometry spreadsheet, I have now successfully transferred the dist, which is a spectrum value from the audio, and if I play this one distance will change, and that's good. Now at this point I don't really need to have the geometry to be packed, since next thing I want to do is to extrude them, so I'm gonna unpack, and while doing the unpacking I want to transfer the attributes as well, so that I can keep the distance attributes for each point. Yeah, and probably before doing the unpacking I would like to transfer this dist attributes to the primitive, since I'm gonna extrude each primitive by the same number. So I'm gonna use attribute promote and from point to primitive I'm gonna promote the distance attribute. And if I look at the primitive, yes, I have this distance, and if I look at the unpacked one, I still got this distance. Okay, that's good. Now here comes the programming part in order to extrude these triangles in a normal direction with the distance value. I think there could be two ways to do this. One is to use the for each loop together with the extrude node, but since that's iterating one by one, the triangles one by one, and that is a bit too slow, since I think it's single threaded operations. So what I'm gonna do is to use the wrangle to create the extruded column for each triangles. Now I'm gonna use the primitive wrangle, and okay, so for each primitives I would like to get 3 points, so I'm gonna name that BTS, and that comes from the primitive, so prim points at prim num. Okay, and I'm gonna look through all the points and get that point. Okay, and what I would like to do is to move those points to the normal direction of that primitive face with the amount of distance which is stored in the attributes for the primitive. So I'm gonna make a new PTS as an array to store the moved point. First of all, it's gonna be empty, and let's get the distance value from the dist attribute. And also let's get the normal vector from the normal of the surface. I mean the primitive mesh. And let's get the point position for each point, which is 0.0 p at pt. Okay, now the new position, which can be calculated from this position, adding the normal times the distance, will be the new position. Will be position plus normal times distance. Okay, and finally use that to add a new point. New pos. Okay, now I seem to have those points. Great. Now this is only a point right now. I have to make some primitive out of this, obviously. Now before doing that, let's add those new points inside a new PTS. And first thing I would like to make is the top part, top triangle. So I'll name this top and call the add prim. And there will be polygon, so I'm name it poly. And the next parameters that I have to put for this function is the 3 points in order to make a triangle. So that's stored inside a new PTS. So new PTS 0, new PTS 1, new PTS 2. Okay, now I have those triangles. Now I want some side faces as well in order to make it as an extruded column. So for that I have 3 faces size for each column, so I'm gonna use the for loop. And length of new PTS or PTS, whichever you want, which will always be 3 because everything is triangulated. And int side equal add prim and 0 poly, and this time it's square, so there's gonna be 4 points. Now the first point will be PTS 0 I, and second one PTS I plus 1, but sometimes if I becomes 2, I plus 1 will be 3, which you cannot get from PTS because PTS only have 3 values, so I have to get the remainders using the modular like this. Okay, and new PTS, the same thing here. And new PTS I. Alright. Now I have those sides. Now one thing I would like to correct or change a bit is that right now you see that those long columns, sometimes there's too much long columns here, being too exaggerated compared to the other one. So I guess I would like to set the maximum distance for the extrusion and somehow smoothen out the overall extrusions. So for that I can go to around here after getting the channel value here. Let's look at the distance. Yeah, here. I could do some kind of remapping and to this distance value. So let's do that. Before doing that, let's go back to the chop channel to see what the wave looks like. And let's see the maximum value. What could be the maximum value here? Now, maximum could be around 20 or 30. But most of the time it doesn't go above 20. So first of all, I could fix the maximum to be 20. So whenever the value goes up above 20, just trim it to 20 value, the value 20 that I want to do now, that I want to do that. And for the other value, like really low told columns values, I might want to remap it using some kind of ramp function so that everything goes a bit average, more of a smoothed mountain, not like this spiky mountains. So let's do that. So I wanted to make the maximum to 20. So what I can do is to go after the channel and use the point wrangle. Name this remapping. And first of all, the distance, I'm gonna make the distance to be, okay, let's get the distance with the variable dist. And first thing I would do is to set the minimum or maximum, no, minimum to 20 or distance. So if the distance goes beyond 20, it will cut it or clamped to 20. Now and next thing I would do is to use the ramp to remap those curves. So I'm gonna first get the ramp attribute, ramp parameters, ramp float. I'm gonna name this ramp. Okay, apply. And okay, in order to use the ramp, I need to remap this value distance to 0, 1. So I'm gonna do like this: fit dist 0 to 20, since I know that maximum is 20, to 0, 1. Okay. Now I'm gonna use the ramp, ch ramp, with the name of ramp, with the value dist. Okay. And finally, dist equal distance times 20. Or I would like to make the maximum extrusion to be somewhere around 3, so I'm gonna set it to 3. Okay, now right now the curve is straight up, but if I change to something like Bezier, this one is Bezier, and add another point and bring it right to the left, to the left. Now everything, the mountains got a bit more smoother than last time, less spiky than the straight one. Everything got more expressions more detailed expressions and looks good, I think, if I play this. Yeah, this is good. It's good. Now this is about everything I wanted to do. The last thing I would do is to maybe color those color those columns depending on the value of the height, the extrusions. So let's make the color value inside a primitive wrangle. I'm gonna name this extrude. And let's see the geometry spreadsheet. There's a I think so there's a distance value in the primitive and nothing in the point. I guess I could just use the distance primitive value to color. Now some of the distance value have 0, and that is because I have added a new primitive inside a primitive wrangle, so I needed to add the distance attribute to that newly created primitive as well. So I'm gonna set prim attriv 0, name will be dist, and the value, to the top, and the value could be, since that's the top, I could just use the same distance value from the current primitive. Okay, now same for this one, set prim attriv 0 dist side f dist. Okay, let's look at the geometry spreadsheet, and there's still some 0 but much less. I guess those 0 are the one that's not extruded, so I guess it's fine. Now let's try to color this. Color, and use the ramp from attribute dist, and I have to change this to primitive, and yes, it's working. Yes, I think it's working. Now if I play this, let's change this color a bit. Cool. Yeah, that's all about it that I wanted to do. Thank you.